Swayam Prabha. Digital India. Educated India.
Welcome to the lecture on the Numpy. In this lecture, we are going to look at what Numpy library is about, and we will be seeing how we can use the Numpy library to do some numerical operations on it so that it will come in handy in our upcoming lectures. Let me just introduce you to the Numpy library. Basically, Numpy is a Python package and it stands for Numerical Python. It is a fundamental package for numerical computations in Python. So, if you want to perform any numerical operations, then Numpy library will be used. And it supports n-dimensional array objects that can be used for processing multi-dimensional data. And it supports different data types. We've already seen Python arrays in our previous lectures. To recall what array is, an array is a data structure that stores values of same data type. So, if you are creating an array, then all the elements in the array should be of same data type. We've also seen another container called list, which can contain values corresponding to different data types. But arrays in Python can only contain values corresponding to the same data type. So, we've already been introduced to what Python arrays are. In this lecture, we can see what are the advantages of using Numpy array. A Numpy array is a grid of values all of the same data type and is indexed by a tuple of non-negative integers, and Numpy is one of the core libraries for scientific computing in Python, and it also provides a high performance multidimensional array object, and using Numpy mathematical and logical operations on arrays can be performed. So, that is why we prefer using the Numpy arrays over built-in arrays in Python. So, in Python, the number of dimensions of the array is called as the rank of the array, and a tuple of integers giving the size of the array along each dimension is known as shape of the array. So, once you have an array with you, if you want to look at the shape of it, then it is going to give you a tuple of integers giving the size of the array along each dimension. As we know that Numpy provides a high performance multi-dimensional array object, and the elements in Numpy arrays are accessed using square brackets like the other arrays, and it can be initialized by using the nested Python list. But there are several ways to create arrays. For example, you can create an array from a regular Python list or tuple using the array function. I am creating a list which contains the values ranging from 1 to 6, and the name of the list is my list, and you can see the output that the values are enclosed inside the square brackets. So, to create a Numpy array, we first need to import the Numpy package. Before even importing the Numpy package, you should have installed the Numpy library in your machine in order to import it in your Spider or in any of the IDEs. So, let us see how to install the Numpy package. So, you must install Numpy in order to use it. So, you can install Numpy by going to the terminal or command prompt and typing pip install Numpy. So, this is how we install the Numpy library or any of the libraries that are required, but I am sure you would have already installed the Numpy library in order to use it. This is just a demo on how to install the library. Since I already have Numpy in the machine, it says requirement already satisfied. So, let us just go back to the IDE and start working on it. So, I am importing the Numpy library as NP. So, NP is just an alias to the Numpy library. So, whenever I am going to use any function or access any function from the Numpy library using a dot operator, then I am just going to refer it as NP, not as Numpy. So, once importing, you can call the numpy.array function. Basically, array is one of the function that is used to create arrays in Numpy, and I am using a dot operator to access that function from the Numpy library. Since I have imported it as NP, I am just using np.array, and the basic n-dimensional array is created using an array function in Numpy as follows. I am using the array function from Numpy library, and every Numpy array is a grid of elements of the same type, but Numpy provides a large set of numeric data types that you can use to construct arrays. So Numpy tries to guess a data type when you create an array, but the function construct arrays usually also include an optional argument to explicitly specify the data type. So if you see here, the first argument to the array function is myList, which has a list of values from 1 to 6, and the next argument is dtype is equal to integer, which specify that I am going to create an array with the data type integer. If you are not providing anything, it will automatically guess a data type when you create an array itself. But if you want to explicitly specify the data type, then this is how you should be doing it. So I am creating an array using the array function from Numpy, and I am just printing it. So the array is created now. So now I am printing type of array. So this basically gives you the data type of the object. If you print it, the output is class numpy.nd array, because Numpy's main object is the homogeneous multidimensional array. It will give you the type of array as numpy.nd array irrespective of the dimensions of your array. The next thing is len of array, which is going to give you the total number of elements in the array. So the total number of elements in the array is 6, and you can also get the number of axes of the array by giving ndim, which stands for number of dimensions of the array, that it says 1, because you have only one dimension to it, that it means that you have only one axis to your array. So now let me just check the dimension of the array. So dimension of the array is going to give you an output of tuple of integers indicating the size of the array in each dimension. We know the dimension of the array is 1, and let's just check the size along each dimension. So automatically you will have a vector when you create an array. So you will have 6 rows with 1 column, that is why you have 6 comma and nothing. But the shape of an array can be changed with various commands. I am going to use a command called reshape that is going to be used to reshape your array. But you note that the following command will return only a modified array, but it is not going to change the original array at all. So let's see how we can use the reshape function. So 3 comma 2 represents it is going to reshape the column with 3 rows and with 2 columns. So I have reshaped the array which has 3 rows and 2 columns now, and after reshaping it, if you check the shape of the array, it is going to give you the output as 3 comma 2. We have reshaped the array as with the dimension 3 comma 2. But if a dimension is given as -1 in a reshaping operation, like the example that I have given, then the other dimensions are automatically calculated, because the first argument 3 represents how many number of rows it should have, and the -1 represents the other dimension is going to be calculated automatically by the Numpy library, because this is just a toy example on to illustrate you how the arrays are created and how we can perform some operations on arrays. But if you are dealing with a large set of array, then in that case you are not sure about the dimensions of your array, and then if you just want to reshape it according to your desired dimension, then you can just use -1 as any one of the dimension, because in order to use reshape, at least you should be specifying one dimension exactly, and the other dimension can be calculated automatically by the Numpy array once you fix -1. So here I fixed -1 along the column dimension. So you will have 3 rows and 2 columns. This has been calculated according to the size of your array. Then, so basically it depends on the number of elements that the array consists of. Since I have 6 values, I have just given it as 3, so it is going to reshape it as 3 comma 2. So that is what it has. But now if you check the dimension of your array using ndim, it just says as 2, because you have 2 axes to the array now, one is row and one is column. So the dimension of the array is 2. So we can also initialize the Numpy arrays from nested Python list as well. So initially we had only one list as an argument to the Numpy array, but here I am going to create a Numpy array from nested Python list. For that I have created 3 sets of lists having few numbers to it. So I have 3 lists, my list 2, my list 3, my list 4. I am using the array function from Numpy library, and inside that I am going to give list of list as the elements that needs to be passed in as an argument. So if you can see here, my list itself is a list, and I have given 3 lists and then given square brackets outside of it, and inside the list also I have 3 lists to it. So if you just print it, it is going to give you the output like this. So you've created an array called mul_arr which has some values to it. Now if you check the shape of it to check the dimension, it gives us 3, 5 since it has 3 rows with 5 columns. And you should be able to reshape your multi-dimensional array as well using the reshape function, and I am just reshaping the multi-dimensional array as 1, 15 so that I can have the array values in single row with 15 separate columns. And then we are going to look at some of the attributes that you can fetch from your NumPy. So I have just created an array called A which has 2 lists to it. So it has 2 rows and 3 columns. That is the shape of the array. So shape is one of the attribute. As I have told you, there are several ways or there are several commands that is used to reshape the array, but I have given you an example on how to reshape the array using the reshape function. Here there is another method which you can use to reshape the n dimensional array, because a dot shape basically gives you the dimension of the array, and I am just passing a tuple which contains some integer and which also describes the dimension of the array as the input. I have reshaped my array with the dimension 3, 2. So now the reshaped array is given here, and I have also mentioned how to reshape the array using the reshape function. You will also be able to create a sequence of values and then create it as an array using the range function. So I have given range of 24. So it is going to give me a sequence of values starting from 0 to 24 as a range. But the downside to use the range function is you won't be able to see what are the values that are there under the created range. It is just going to return range of 0, 24 as an output when you print the R. So the range function is often used when you are dealing with control structures, and if you want to iterate a value with a given sequence of values using range, in that case range will be very helpful. But to create a sequence of values, we can use a function called arange, that is from the NumPy library. It is called as arange because from NumPy it is going to create an array based on the sequence of values that you've given it as an input. But it is going to return an array, that is why the function name itself is arange. So the arange function syntax is start value, stop value and the incremental value. So it basically takes in 3 arguments. I have just given only 1 argument, so by default it is going to take that value as a stop value, and if you are not given any start value, it is going to start from 0, and by default it is going to increment the value with number 1. And I have given 24 here, but you would have got till 23. That describes that the stop value, whatever I have given here, it will return only till n minus 1. So if you have given 24, it will return till 23. If you check the dimension of the array created now, that is A, it is only 1. So if you can see here, this is the original array. I am just reshaping the array A. Given 6 as the first argument, it is going to keep all the values into 6 vectors, and each vector will have the size 4, 1. Under each vector, you will have values in 4 rows and with single column. From 0 to 3 is a vector, and it has a dimension 4 cross 1, and the second vector also has 4 values to it in a single column, similarly in the other vectors. So I have given the first dimension as the number of vectors it should have, or under each vector what is the size, that is 4, 1. That represents the number of rows and number of columns that you are going to use to reshape the array. So this is how we can reshape the array using the reshape function, and you can as well perform some of the arithmetic operations on the NumPy arrays. So I have created 2 arrays. So the elements inside the x and y arrays are of float 64, and you can perform some of the arithmetic operations like addition, subtraction, multiplication, division and so on and so forth on the arrays that you've created. So let me just take you through one example on each. So first we are going to see add. So the numpy dot add performs the element wise addition between two arrays, and the syntax is just you can use the add function, and inside the function you can specify the two arrays that is going to be used to do the addition, and you can do that, or you can do the element wise addition using the plus operator as well. So I am illustrating the addition using both plus operator and using the add function. So as I have mentioned earlier, it is going to do the element wise addition. So the first element of the array A, that is 1. So the first element of the array X, that is 1, and the first element of the array Y, that is 5, will get added. 1 plus 5 would be 6. So that is the output that you are seeing here. So similarly, it does the element wise addition on all the cases. And you have two output for one plus operator and for one using the np.add function. Similarly, you can perform the element wise subtraction between two arrays using the subtract function from numpy, and the syntax remains the same, and you just need to replace the same command with the minus and the subtract function, and it does the element wise subtraction. And you can perform the element wise multiplication between two arrays, and using asterisk you will be able to do element wise multiplication between two arrays. But if you want to get the dot product of two arrays, then you can use the function called dot. X dot of y is going to give you the dot product of the two arrays x and y, and you can use the dot function either by applying it on one array and then using it on the other array, or you can just use np dot dot, and inside the function you can just give the two desired arrays that needs to be multiplied. And similarly, you can also perform the division between the two arrays, that is x and y, by using the slash operator or by using the divide function from numpy library. So all of the addition, subtraction, multiplication and division using the required commands is going to do the element wise operation between two arrays. And I have given a snippet on how you can use the other functions on the arrays. I have given the function name in the first column, and I have just also added the description along with that. And you can refer to it basically in order to explore more functions that we can perform on numpy arrays. Then we are going to perform some operations on numpy arrays. The first thing is sum. So using the dot sum from the numpy library returns the sum of all array elements or sum of all array elements over a given axis. So the syntax is numpy dot sum, and the first argument is the array, desired array, that is going to be used. The next one is axis. So let's see how we can use this function. So I am just printing np dot sum of x. If you can look at here, I am accessing the function sum from the numpy library, and inside the function I have just given only one argument, that is x, which is the array that we have already created, and I have not given any axis value. So by default the axis is none, so it is just going to compute the overall sum of the array x. So I have printed the output of x. So this is what the array x contains, and by using np.sum on x, it computes the overall sum of the array x, 1 plus 2 plus 3 plus 4. But if you are providing a value in the axis argument, then it is going to perform accordingly. So the axis values can either be 0 or 1. So the 0 represents performing the operation on rows, and the 1 represents performing operations on columns. For example, it computes the sum of each column on the array x. For example, I have given axis is equal to 0, then it is going to take the value from the first row and then value from the second row. Though it is going to hop across the rows, it is just going to give you the sum of each column. So if you see 1 plus 3, it gives you 4, and 2 plus 4 is 6. So it basically, if you give axis is equal to 0, it computes the sum of each column, and by giving axis is equal to 1, it computes the sum of each row. So the each row sum will be calculated by hopping across the columns. That is why I have given 1. That is 1 plus 2 will be 3, and 3 plus 4 will be 7. So similarly, you will be able to use any Python built-in functions like mean, median instead of sum. You can explore more on that, and you will also be able to perform the other functions that you have already created on the numpy array as well. In this lecture, we've seen what is the advantages of using the Numpy arrays over the built-in Python arrays, and in the upcoming lectures we will be seeing how these Numpy arrays can be used to perform the mathematical and logical operations on multidimensional data. Thank you.